Hey everyone, this is a video that's going to be talking about strong acids and bases. And before we get into the strong acids and bases, I first have to give this word, we have to know about the word dissociation. So the term dissociate means splitting apart of something. It's kind of the opposite of associate. So when you dissociate from something, you're splitting apart. And we'll talk a little bit more about what that looks like in a molecule, but if I have a strong acid, it means that it breaks apart completely. So it dissociates completely, meaning that every acid or base molecule will break apart. And this seems kind of counterintuitive because strong, a lot of people think of strong as being able to hold together, but strong actually means it's the concentration of the acid particles going to be high in the solution, and the only way they can get high concentration is if they break apart. So strong acids break apart completely. If it's a weak acid, they do not break apart completely, and we are not going to talk much more about them until later this year. So second semester, we'll look more at weak acids, but strong acids break apart completely. There are strong acids that you should memorize, and these acids, if they come up in the AP test or if they come up in a class, then you should automatically kind of recognize, oh, this acid is going to break apart completely. So hydrochloric acid is the first one. This is an L, not an I. So HCl, hydrobromic acid, HBr, and HI, hydroiodic acid. And if I look at a periodic table, you will recognize that these Cl, Br, and I all fall in this column of the periodic table. So Cl, Br, and I. F is not one of, so HF is not a strong acid. It starts at Cl, and it turns out that HF is a weak acid, but HCl, HBr, HI, those are the strong acids. And what I'm going to do is let's just take these three first and look at how they break apart. So HCl, if I take HCl and I put it into water, it splits apart immediately into two things. H, and that's got a positive charge, and Cl, which consequently has a negative charge. So if I put a bunch of these in here, H plus, Cl minus comes out, H plus, Cl minus. You will never find these together in solution, okay? For a weak acid, something like this, if I have a weak acid, let's say I have HF, which is a weak acid, and I put this in water. Well, then what happens is in the water, you actually have a lot of HFs sticking around together, and they don't break apart. And you might have one of them out of several thousand or million break apart, but here, most of them stay together. Whereas in a strong acid, they all break apart. Hydrobromic acid, very similar. It breaks apart into H plus and Br minus. And hydroiodic acid, H plus, I minus. I call this the friendly acid because it says hi, but you don't want to ingest it or come in encounter with this because it's not a very nice acid. The other four strong acids. So I have nitric acid, HNO3, perchloric, chloric, and sulfuric. So let's take a look at these three here next before we look at sulfuric. Similarly, you're going to have this thing, if I put this in the water, it's going to break apart into, well, once again, H+. But then the NO3, if we recall, this is what we call a polyatomic ion. Polyatomic means many atoms in the ion, and it stays together. So it's NO3, and the whole thing has a negative charge. So this, remember, this is called the nitrate group. So splits apart H and NO3. Perchloric acid similarly breaks apart in H plus and ClO4 negative. So that is, this is the perchlorate ion. And then chloric acid breaks apart also into H plus and ClO3 minus. And if you can't, if you're seeing a pattern here, H is always positive. Whatever it's connected to is always one negative charge. Chlorate ion is chlorate ion, so ClO3 negative. Okay, so those are all the acids there. The last one is sulfuric acid. Sulfuric acid is used in car batteries and other things, industrial uses. And when this breaks apart, it's a little different because there's two H's here. So if I were to dump this in the water, what ends up happening is this H plus breaks apart, and then you end up having HSO4 negative. So this first one will always break apart, H plus, HSO4 negative. And then this thing here actually has the potential to break apart further, but it's not going to break apart unless I start reacting it with something. So if I start adding what we call a base, okay, bases react with acids. If I start adding base, it'll react with the H plus, but then it'll eventually react with the HSO4 negative. And if that happens, if this breaks apart further, then what can take place is it'll look like this. You'll have more H plus and SO4 2 minus is going to be here. So you might have an H plus and H plus and SO4 2 minus. So this could further happen if I keep reacting it, but this thing isn't going to break apart very easily unless you start reacting it with something. Okay, so those are the strong acids. Strong bases. Strong bases are, I got 6 of them, but, and this just kind of varies. There's some people say some are strong or not, but these are a little easier to memorize, I think, because if you look, there's a pattern. So lithium hydroxide, OH is the hydroxide ion, and a base is anything that really, for our purposes, is gonna have OH minus in solution. Okay, so for our purposes, for now, strong bases, if you're gonna have OH minus in solution, that's gonna be a base. Here, if you notice, for acids, they all have not OH minus, but H plus. Okay, so if I have H plus in solution, so acids donate H plus, whereas bases donate OH minus. So lithium hydroxide, sodium hydroxide, potassium hydroxide, and if you look at the periodic table, lo and behold, these are the things in the first column. So anything with an alkali metal, and to be honest, rubidium, cesium, they could be used too, but nobody really uses those because they're not that common. Lithium hydroxide, sodium hydroxide is drain cleaner. Potassium hydroxide, those are all things that are pretty common, and those are our main strong bases. And when they break up, you're going to break up into Li positive and OH minus, and this is called the hydroxide ion. Okay, hydroxide is always OH minus. Sodium hydroxide, Na positive, OH minus. Potassium, K positive, OH minus. All right. And then I look at this thing here, and we see that these things all have something in common. Well, not in the first column of the periodic table because there's a 2 here, but I gotta figure that something's up with this thing here, and lo and behold, Mg is in the second column, Ca second column, Sr second column. So magnesium hydroxide, calcium hydroxide, strontium hydroxide, they're all going to break apart. Mg 2 positive, and then there's OH negative, but there's 2 of them because there's 2 here. Okay, similarly for calcium, strontium. So those are my bases and acids. Make sure you get notes on this.